managed to trick you all into having to listen to me for 90 minutes, 60 to 90. So a little bit about me is I kind of learned programming in an opposite way from a lot of people. I went from logic gates to machine code and then to assembly. So, you know, once we get to C and C++ land, it's like, okay, we're very happy high level here. But I always say my first programming language was Microsoft Excel. And so that means that I tend to favor things that are a little bit more kind of declarative in that sense. I started writing C++ 3 years ago when I started my internship at Keysight, which is where I work, and was kind of thrown into the deep end. There was a lot of different C++. It does not look like the C++ 98 of old. The first thing that I remember seeing and being a little bit confused by were initializer lists. And I'm just the new syntax, so many double colons, namespaces. Now, we use these configurables as a base template for a lot of things. And they're based off of an enum, which is a config ID. And each config ID will map to a type. You can think of it as kind of like a struct that's mapped based off of an enum instead of off of its actual members. Oh, and by the way, if you have any questions or comments or concerns, just speak up, raise a hand, and absolutely, you know, help me out. This is my first time speaking. I'm new. But yeah, using enums this much means that I see a lot of enums. And I see a lot of ways to convert between them. This is a seemingly kind of useless conversion, but it happens a lot when you're moving between layers of abstraction. I work in driver firmware, so you know, moving between kind of the middle management software that has APIs that make more sense, and then moving down lower to the drivers. A lot of times there are things that kind of look like this, where you're mapping one-to-one. And how do you do that? What's a good expressive way to convert from enum A to enum B? And of course, the first thing that I tried was just static casting enum A to enum B, which works very well, as long as they are both exactly the same and in exactly the same order, which doesn't happen very often. And when it doesn't, it can be very difficult to tell why, much to my dismay, of course. And this kind of points at a general larger problem, which is, okay, what is a good way to map enums to values? It seems like a relatively simple problem, but there's a bit of nuance here. Now, a common solution is to map an enum like you would map any other type. To use, you know, a standard map or an unordered map. And now, obviously, when you're kind of in the driver space, I say I work on embedded systems, and that's true in the sense that they are embedded in a system, but we have a little bit more resources than you would typically see in an embedded system. But even still, this feels a little off to me. It's something where the plague of non-const expr starts here a lot of the time. And that's something that can be very frustrating when you're trying to write, you know, const expr free functions. You want to be able to test things. And it just seems a little off to me. It seems like it's overkill for something so simple, but it's a relatively common pattern. And there's a reason for that. It's expressive, it's compact, and it's complete. It's relatively semantically correct for what it is trying to do. Now, something that's a little bit closer to a theoretical machine efficient solution, right? Is to use a switch case. And fundamentally this is going to make our computer do a bunch of comparisons. Obviously the compiler can optimize this. It doesn't. So I'm a bit of a sucker for syntax, I admit. And that's something that's not necessarily always the best, but there's a reason that people tend to move towards simpler syntax, easier to use things. And it's simply the fact that we have cases, the fact that we have breaks doesn't actually matter to the core business logic of what we are trying to do here. And now, this switch statement, when we compile it with GCC with O3, will compile to this assembly, which seems to mostly make sense if you think about it, right? I mean, what is an enum underlying? It's just an alias to us for an integer, something that we can assign some sort of semantic meaning to in the business logic that the computer also understands. And pretty much the most natural way, if you have to convert, if you have to index something, so grab something out of a particular enum space at runtime, is to have all of these values stored contiguously in memory, and then you can go to a constant offset, which is the multiple of your enum. Now this is pretty close to that, but it also, funnily enough, has this little JA, the jump if above, and that's handling the default case, right? The enum, the switch statement doesn't know, I suppose, that it can only be getting certain values, and technically you can, pass anything to an enum and feed it into the switch statement. And so that's another branch there. It's one kind of extra step in something that seems like it should be really logical, really simple. Funnily enough, I tested this earlier today, and even without a default case, we still get this jump above, and it compiles to the same assembly, but we also get a warning that says that our result may be uninitialized. Now, it's still XORing our result with itself, initializing it to 0 here. It's kind of funny. It just goes to show that the warnings and the code generation obviously aren't always in lockstep. It may be uninitialized, as in the standard allows it to be.
Magic of undefined behavior is what
Mm-hmm.
it's the magic of undefined behavior.
Yes.
Erroneous. Sure. Yes. 26.
Yes.
Did you try this with returns instead of breaks? I'm just curious if that would result in more efficient code.
I did not. No.
I expect it wouldn't.
No, I don't.
You get exactly the same thing.
Same thing.
Yeah, I know that because my talk is about a lot of the same stuff. I'm looking at this and saying, I'm not going to have to do all that. Yeah, I know that this is the same thing.
It's yeah, it's interesting stuff though, because it's like when you have something that's very kind of integral to all of the business logic that you're making throughout your code, and you're using it in a lot of places. The fact that you have an extra branch in there when you really don't need to have one is just kind of needless. And of course, yes.
He's using 3 space and done.
Oh, yes.
Good man, space and then.
And 4.
He's using 2 and 4.
And 2.
Also. The average. Yeah. I'm just calling for you They did a lightning talk on why we should prefer three space and that last year, or a year and a half ago.
Yeah.
So,
Oh, really? Huh. I haven't seen very many that prefer three space indent, but it is this is probably a case of I was typing some of this in Compiler Explorer and tabbing there.
Sorry.
Okay, so yeah.
Maybe you're gonna touch on this, but if you have an enum where you're assigning values manually, like maybe it's reflecting like 0, 1, then 1, 0 in this, does the same code generate, or is it will need to use like one-to-one checks?
Well, so in the switch statement space, or in the switch statements space, statements case. Not sure why that's so difficult to say. It's really just dependent on what each of the actual values end up being. If you have all of them, at least with optimization turned on, it will usually result in similar code gen to this. But obviously with like kind of small cases like this, you can actually see pretty different code gen with like different numbers of things or different spaces between them. It will, so like here, it's filling in these zeros here for the default case. And different compilers will do that to certain extents. Look like you have.
No, on the street.
But yes, yes.
We'll actually spread out the numbers if the values of it are like, let's say it skips one occasionally, then it will be basically longer in terms of what it will do.
Sure, yeah. Yeah, I mean, the compiler just sees these as integers fundamentally. Well, that's obviously not quite true because the type system does know about them, but eventually they end up as integers. And it's, using the integer as just a multiple for its offset. And we can see that here. It's just, multiplying the actual value by the offset, indexing into the array, unless it's above a certain level, in which case it's returning the default. Now, in our case, we actually don't necessarily need to check that above. Now, obviously, this is dependent on if you are actually, you can cast integers into enums that aren't valid values, but this is kind of the direct mapping that we're looking for. And my motivation in seeing a lot of this was actually in seeing people writing out code specifically. So, creating a static map of enums to values and then using map at enum as just kind of a expressive way to do that. And obviously, if you're writing out the value in the source code, then you can know your enum value is going to be one of the defined enum values in your source code. So this is kind of what we're looking for, right? Is we're looking for, and we can see this, very clearly. It's just doing one operation to index into this value array in memory. It's very clear, where we're grabbing this from. Yes.
One comment from online, default stood unreachable helps the compiler not provide switch.
Stood on.
Yeah, but it wouldn't change that code.
Say it again?
I said, I don't think it would have changed. Oh, it would have eliminated the branch. Never mind.
Default become unreachable, and yes, it helps. I don't know.
If you tell it that it's unreachable and it can figure out that you're right, it can eliminate that jump.
It would eliminate the jump, yeah.
That's equal to 23.
Yes.
Interesting. I think regardless, we're looking for, I mean, the way that we get here, this is the assembly that we're looking for here, right? And now, one problem, obviously, with actually using this implementation raw is there is nothing to stop you from using any other value, you lose your type safety when you are just static casting indexing into an array. You can wrap this in a function. But even when it's wrapped in a function, there's something that's not quite type safe about this. And this one's a little bit harder to spot, but can anyone see it? We can do that, but let's assume that we're passing in a valid enum.
If they're all under one type. You didn't have any one type of assigned integer, for example. And therefore, the
All
value
would be assigned an integer.
There's no guarantee that enum has 5 values.
True.
You go change the enum to have 6 values or 4 values.
Oh, well, you're assuming that it's also 5 contiguous values.
Yeah, that too.
0 through 4.
And we're assuming that they are in that order.
Yep.
So this is the underlying assumption here when we do this. And as nice as our comments here are, there is no way for us to actually enforce this, that this enum actually maps to this value. There is no reason that our enum couldn't actually be implemented like this somewhere else that's separate from the array that we're building to index values from. And it could just be put in a less logical order because we happen to like it more in a certain case. So, okay. This is kind of where my head is at this point. I want something that looks like this, that's expressive like this, that's easy to use so that people will use it, and compiles like this, but with more type safety. So, yes.
The value you're using to index that is a runtime value, right? It's on.
Correct.
It's on compile time value. Okay, so you just.
Correct. Yes, these are indexing runtime values. Obviously, if we make this const expr, if we grab a value out of here, it doesn't super matter what the underlying implementation is because the outputted assembly will always still just be load 42 into register A. It's especially when we have optimization turned on. Okay, so this is kind of a special case map. And so I'm going to kind of go through my process as a relatively new C++ developer, a junior developer, trying to learn a lot of these concepts and build a useful container. And so I'm hoping that for a lot of our senior developers and tech leads out there, that this is a helpful perspective for how the learning process goes. And for those of us who are newer, like me, especially to C++ and kind of the newer feature, this can be a helpful or maybe inspiring thing to help find ways that you can do this in your own code. So my goals for this were to try and avoid making it, an untrue interface. There shouldn't be, little tricks underlying there to as much of an extent as possible. And make it like it's for everyone to use, even though I'm going to be the only one using it for a while. And the first thing, of course, that helps with this is defining a concept for our enum. So here's the first pass at this container. And I called it an enum index. And so it's relatively simple, templated on an enum type, a data type, and a size. And it's essentially just a wrapper for an array that is casting the values into the underlying array. And you can see an example, we have to, I suppose, instantiate with all of the template arguments as is. So we can use this minimal example to create our template container. We can declare what each of the values are, and we can then use them from here. And this does work. If we wrap this in a function so that we make this occur at compile time, when we create our index and then return it, we will get our single instruction that we're looking for, that is indexing into our array. Now, this still has many of the same problems. We shouldn't have to use the at operator to build the entire object in context land and then bring it over. The fact that we have a 5 here is a little bit leaky, because it requires us to know not only, I suppose, how many total enums there are, but what is the biggest one that we might end up actually indexing. And it requires caller discipline to actually initialize everything, to give all of these valid values. And of course, one more issue is that if we don't wrap it in a compile time function to build it, we can't actually make it constexpr, because we don't build it all at once in a constexpr constructor. Obviously, there are many other considerations when thinking about actual library code. So things like, these are all trivial types. They all have to be default constructible. We're not considering things like references or const yet, but we're just kind of trying to build a type-safe wrapper, I suppose. We know what we want to do, and trying to build up a system to make it easy to do that and hard to do things we don't want to. So we have this, and to me, looking at this kind of templated code at first feels like a lot. But this is kind of the attempt to construct everything at compile time. And this is doing a few things. So first is we are templating everything as a value off of these enum constructor helpers. And this was mostly a way that I found to coerce the compiler into seeing this as this. And that's nice, because really we shouldn't need to say, oh, we are building a big map out of enum constructor helpers. The user doesn't really care about that. And of course, we're just including our enum and what it is mapping to for the data here. Yes?
There's a number of constructs in the previous slide that I don't recognize. Is it relying on a certain version of C++, or do I just not know? No.
So this is all C++ 20. And I am going to kind of walk through that, basically that constructor, and essentially my thought process for each of the parts in sequence. So I'm glad that you said that, because if you didn't, then I would be talking to a whole bunch of people who already know this stuff. Yeah, but does this part make sense? The essentially, we have our parameter pack that we're templating on. So that's the ellipsis operator here. And we are saying all of these are going to be this struct. So if you give us a brace initializer list, we're going to assume that it's for that struct. And that's mostly quality of life, mostly a syntax sugar thing. But, you know, I heard once that everything except NAND gates are syntax sugar. We don't need or not. That's just making it easier to read. We don't need that. So next in this constructor, we are taking this parameter pack that we have, this list of enum constructor helpers, which are just an enum and some templated data type, and we are making an array out of them. Something that's really nice to know about a lot of standard library containers, I think all of them, I don't know. I think they have to have a value type defined, type def. But definitely standard array does. It's templating you can actually look at the standard library code, believe it or not. You're allowed to do that. Well, if you look at it for long enough, it starts to make sense. Little pieces of it. Yeah.
But don't copy what it does, because that's undefined behavior for you to do it. Underscore capital T, you're not allowed to do that.
Wait, why?
That's a reserved identifier for this implementation.
Oh,
Underscore capital letter, reserved in global scope.
well, there you go. Okay.
Why do you need that on a template parameter?
Why do you need that? It's to protect it from you, because if you put pound defined underscore capital T, so that's why it's reserved, so that you can't override what they want to do.
That actually makes sense.
You too. Know your box.
I have been bitten by that. So.
Huh. I didn't actually know that. So that's very interesting. I mean, it makes sense. Yeah, so implementing this was about the first time, by the way, as a bit of an aside, that I managed to break the CI builds. Imagine my surprise that not all C++ compilers do the exact same thing. I was incredibly shocked to learn that. I'm like, oh, there are different C++ compilers, and not only do they do the same thing in different ways, but they actually do different things sometimes. So yes, anyway, we have a value type defined in our standard library containers. So what this is doing is getting the value type out of the array. This is a bit of a roundabout way of doing it, but it was the way that I found to get this type. Was declaring the type of an array that we build around the parameter pack, getting the value type, and then getting the name type. Because if we look earlier, we do have these using statements. And if these are public, you can just grab these to be able to get types locked down, which is actually very useful. That can be very helpful sometimes to be able to alias types in this way. And then we do some checks. And this is the part where I start to get actually kind of excited, because it's like, hey, this is the first time where we're actually offering something above what a, just implementing this with, I suppose, a switch statement might do. And we can do this when we're saying, we're static asserting that the size of the array that we are passing in, so this helper array, is equal to the enum array size. And we'll just put a pin in that for a bit. But let's assume that we have a function that we can call on an enum that tells us how big of an array we need to index everything just by using a constant multiple. And then we can also check that this doesn't contain duplicates, because that was another thing that I discovered, is that if you're passing a whole bunch of these in, there is no way to make sure that you haven't defined the same enum twice. And that's something that can be very frustrating if you go back and look and you see, oh, I set example A to be this value. Why is it not becoming that? Well, it's because you set also example A to be this value later. So this is nice. This is actually something new, something, a small bit of extra niceness for me, right? I mean, this is nice kind of library code that I'm writing for myself at this point. But
So
yes,
you're doing the and trick to static assert here. Is it C++ 20? If we get to that might be static assert.
No, C++ 11 had the reason required.
Oh,
You just
that's
need a
right,
comma.
that's right.
You don't need the and,
Yeah,
just a comma and the
The other
string.
way around. So
Yeah,
That's the C assert trick.
Did you catch that?
so you can just
You,
use comma with the message, and
yeah,
you'll get
comma
the
and then
answer.
message, and then the compiler knows that the second parameter is the message for if the static assert fails.
That is nice. Yeah,
The C++ 17 that removes that requirement.
gotcha.
Scott, a quick question.
Yes.
I don't know if I heard that correctly. It sounded like you said enums will actually let you define the same enum value.
No, but when we're creating this struct, right, we're mapping values of enums to values. This is some way that when we are doing this make enum index here, that we don't put example A twice.
I mean, you could also put a different enum, value from a different enum. The array would fail to compile.
Mhm.
The template would be fine. Because it's a
That's-
placeholder in the parameter hash.
Yeah.
That is true. And that would probably be a pretty nasty compiler error.
Yeah, I mean, using the value type from the array is nice. Like otherwise you have to misspell it.
But yeah, that's, I suppose, but yeah, that's, I suppose, the idea behind those assertions there. So now we're going to kind of dig into, okay, it would be great to be able to constrain my code that I'm writing so that I don't write obvious mistakes in my source code. I'm not getting a ton of dynamic values that I don't control in driver code, right? A lot of the times when I am writing indexes like this, they are ones that I should be able to not make mistakes on. So this is a very simple checking if the array contains duplicates. The only special thing about this that I discovered with my C++ 20 adventures is that you can do this at compile time, even though it's doing for loops and mutating things inside of the loop. We can still, and I suppose we can template on the entire array. That was something that I was trying to do at first by doing a const eval function, passing in an array as a parameter. You can, the trick, I suppose, of doing an auto array and then just passing in the value as a, as a compile time parameter, because that's what the template parameters really are. They can be type names, they can be values. But that lets us do more things on them, and the compiler knows more strongly, I suppose, that it's const expr. And I'm sure that people here know the reasons why, I suppose, const eval parameters can't be considered to be const expr.
Never are.
It
Don't
seems
ask for good
strange.
reason. They just are.
They are for good reason, or don't ask for the good reason. And just I'm sure, yeah. Okay, so now how do we get our enum array size? How are we checking that we actually passed in? Because what this is doing, right, is it's checking that we actually defined every enum. And this is something that you can get with switch statements, right? Like compilers will warn you if you didn't enumerate every switch case. And in some cases, your linting tools will warn you even if you specify a default. But so, okay, let's assume that we can figure out what our max enum value is. If we can do that, then we add 1 to that to get the size of the array that would contain that value as its highest index. Okay, how do we get our max enum? Assume that we can get all of the enum values of a certain type. If we can do that, then we can do a relatively trivial implementation of looping through all of them, checking if they are bigger than our biggest enum, which this doesn't necessarily have to actually be correct, but it is in our case. You can define an enum to be smaller than numeric limits int min, but we are limiting our search to a relatively small area for a good reason. And so, okay, we get our biggest enum. We can figure out what the array size actually needs to be. How many enums could there be? Exactly as many as you say there can be. Now, the way that we go about doing this is a little bit roundabout, but it's essentially guessing and checking every possible value from -10 to 100. I chose these values in particular because there are, some enums that have defined values for registers. It's a really common thing is to have an enum that represents a certain value to a register, and you set it equal to that value. So they're not necessarily all completely contiguous, and they don't all use their default values, but every single one that I found was the lowest value was -1, and the highest were in the 50s. And so this is definitely more of an application-specific limit. But so now we're going to do this standard make index sequence for the number of possible enums that we've determined. Now, standard index sequence is something that puzzled me very much for quite a while. The real power of it is that it essentially, yes?
I think that sequence is not a function. I don't think you can run that. It sounds like a function, but it's a type.
No, it returns the value.
Make index
Yeah,
sequences.
that's like you've got parens and then braces.
The
inside
braces are
parens.
unnecessary, yes.
You don't need the parens.
Probably.
Well, you don't need the braces. I mean, that's how you initialize. Those
Probably
braces-
don't need one of those.
The value. Oh, yeah, that's fine. That'll compile how it is. It might just return an unnecessary braces warning and runtime.
It's possible. Yes, looking at that, it does look like it's calling the function on basically just like an empty initializer list, right? But what make index sequence is doing is it is making a type that is templated on every single value from 0 up to whatever value you give it. And that's the key concept that I didn't really get for quite a while. So the way that we're using this is we're templating our function now on some number of size t. And that's, of course, what the parameter pack indicates, the little ... after the size t in our template definition there. And our function is templated on this, and we pass in the index sequence to the function. And this, we're not actually using the index sequence at all. We are essentially just doing this to get its list of template parameters, which is all of the enum values that we want to check. So we build an array. This size of ellipsis operator will return the size of a parameter pack at compile time. I think it's a little bit confusing that it does this, I suppose, or that this is the particular syntax to do this. And then we are expanding each of these into a comma-separated list of this function has value, and we are passing another compile time parameter here. So let's take a look at this, break this down. So I mentioned that we are first templating on this sequence of numbers, right? And the way that I am using index sequence here, I'm not sure if this is correct. This might be a bit of a hacky workaround, but it's essentially just to pass in the value, and the compiler deduction will then fill in our types, and we can use this list of numbers I here, because that's inside the braces. It's a compile time parameter of index sequence. And so then we're creating an array of these numbers after we apply a function to them. So we have the size of our parameter pack. So this is a valid array of however many numbers we give it. And we are checking, okay, that it has a value for E, the type. And this cast val function is not named particularly well, but it is essentially shifting the enum because we are giving it an index sequence. I'm realizing now that we probably could have done an integer sequence and skipped the process of going up and then going back down. But that is what this is doing, is we defined our minimum and maximum value. We took the difference between them, said, okay, this is how many enum values we have. We passed that in, and now we're shifting it back down. And it's a bit of a roundabout process. Yes?
Probably an appropriate time to mention that C++23 add an underlying type trait so that you didn't have to guess that it's integer. You could use the type trait to say, oh, this is a uint8t or whatever the enum actually happened to be.
So the traits of it, two underlying the 23, right? Function, but the traits exist.
Oh, the traits before that? My mistake. Then you should have used the type trait.
Is that the magic?
I think it has to be.
Yeah, I think so.
What
I don't know how you do it.
magic in what sense?
Magic, it means that it requires the compiler. You can't write that type trait. The compiler writers have to write it. It requires compiler internal knowledge to create.
You need a built-in.
A lot of the type traits you can actually write by hand, but there's a handful of them that can't be written by hand.
Okay. And so that's, I suppose, just checking to make sure that we are converting it to the correct underlying type.
Yeah, in your code where you have like int -100 to int +1 like this. Well,
Yes.
That's auto, but that's going to be deduced as int. This is a valid place too. And here you would have used E underlying type or whatever, underlying type of E in place of auto. And then like would have had to have guessed in there. So that if it was an int8t or something like that, then it would be an int8t instead of a 32-bit signed image, for example.
That's fair. I suppose in this case, even if it's an int8p, we're still within the unsigned range of that. So we didn't happen to step on that particular landmine.
But I don't think there's a make integer sequence here that would have helped him. You can't say from -10 to +100 of that. Anyhow, so you still would have had to have done some magic on your
The
own.
upset thing is
Yeah.
the standard thing.
Okay. A known.
Technique that is-
Less than voodoo.
All right, let's see. So we're creating our numbers. We're creating this comma separated list of the results of these function calls, has value. And so this is kind of the linchpin here, right? We assume that we have a function has value for enum, and we pass it an integer, and we say, is this a valid value for the enum? I think then
We're heading towards a user pretty function, which is nasty.
not quite. But effectively, yes. Oh, I had a little slide here on parameter packs, and wanted to say to anyone struggling with parameter packs, it's okay. Parameter packs are tricky. They're very difficult for me. This Stanford blog on parameter packs is really helpful. It explains that actually that little ... operator is not, it's not doing one thing. It's not like a macro that is like copying whatever's before it, as you might naively assume if you are me. But it's actually like, I think like 13 different operators that it's actually doing technically. Between folding and expanding into comma separated lists and how you do derived. Regardless, you can always just play around with them. Compiler Explorer is wonderful. And you can plug them in until it compiles. Sometimes you won't understand exactly what is going on, but that's kind of the case with a lot of this stuff for C++ for me.
You should ask if your audience knows what Compiler Explorer is.
Oh yeah, does anyone not know what Compiler Explorer is? Yeah, Godbolt.
I'm actually surprised no one raised their hands. Okay.
Well, you don't know what Compiler Explorer is? Do I have a treat for you? Compiler Explorer,
Or
Godbolt, godbolt.org, lets you see in a very nice format here your code, how it compiles. You can choose from a whole bunch of different compilers. This was very helpful once I started breaking CI, because I could go and pick, oh, this is the one that we were using that it didn't compile on. And I could read the compiler warnings and fix it without having to run another CI build and then wait an hour.
It's like 30 different.
Oh yeah, yeah. So you can do a lot of languages. Yes, Compiler Explorer is very cool. If I can start just writing template code, then you definitely can. And the further you go, the deeper you get into const expr land, and then eventually your entire program won't exist, and it will just return a single number.
This is the way.
Couldn't you have just made it return that number from the start? But it came up with that number.
It came up with the number.
Complicated way.
Okay, so this is the particular trick for figuring out if an enum has a value or not. And of course, as soon as you see ifdef gnuc or ifdef msc, you know you're getting into interesting things, because these are checking what specific compiler you happen to be using at the time, because they do different things. So what this is literally doing is it is looking for the function name of this function, which we have templated on the enum, the value of the enum itself. And we see, okay. Can we find, and yeah.
Sorry, we're all discussing that you have an open paren right there in the quote, which is correct. But it's hurting our brains because we see the
Oh. Yeah. Yeah, that's the new paren quote operator. You can overload that. That's your new volatile move constructor.
Find it somewhere.
Yes. So what this came from was first looking at, or Googling, trying to figure out, is there a way that we can find this? Finding, I think this is the approach that the library Magic Enum uses for a lot of things. It goes further and actually takes the value out of there. I know Ben does this in his standard extensions library as well. Well, I think, but that's how you do the enum to string view or type to string view, which gives you a very limited kind of reflection, because unfortunately the compiler cannot read source code yet. It can't know that you have to go to the bottom of the enum list. You have to, look at it, and is that the biggest one? Okay, that's the one that we need. So this is kind of a fun way of going about that. I was very surprised to see that standard source location is a thing, and that you can compile based off of that, but it made me very happy. Yes, did you? Sorry. I thought I saw a hand. So yes, this is the linchpin of our, okay, is this a valid enum? We're counting them very simply by passing in our array, and this is a const_expr function, so we can iterate over this array. I'm not sure why, off the top of my head, the syntax looks so weird.
It's reference to array syntax. It's
Reference to array.
Yes, it's just how it looks.
Yeah, it's been a little bit on some of this. This was kind of fun going back through and being like, oh, I remember implementing this first this way. It's the type of the array. This is a reference to an array that we're passing it in at compile time. And we're just counting how many of them are true, because we passed in our list of every possible value earlier. That wasn't actually every possible value, but every one that we care about. And now we're going through that list and seeing, okay, how many of them are actually valid enums? And we can use this count to get the size of the array that we're going to need to index them. Now, not to actually get the size, sorry, because this is to get the enum values. So not the size of the array that we're going to need for the index, which we want to do constant, but just to get the size of the array of the values, because we're trying to get all of the enum values here. And now that we have an array of all of the valid enums, we have that at compile time in const_expr land. We can loop through them and find the biggest one. And we can use that as our template parameter. So all of this came from the fact that earlier we needed to put a 5. We needed to put a 5 in here, right? Because there are 5 values. There are 5 enums. We want to make an array with 5 things in it. It took a while to get there. But now we don't have to put that 5 in there anymore. So that makes me very happy. As I think I already mentioned, I'm a sucker for syntax. It's, yes.
I thought in previous law you should get all the enum values.
Mhm.
Instead of imposing the application a good range for enums that you're searching for, could you not just sort the enum values, take the enum max?
So the enum values that we're getting are only within the range that we're checking, because the way that we're getting if it's a value or not is we are guessing and checking. We are saying, okay, we're templating this off of an enum value, and we are looking at the function name. And a nice little quirk is that if it is defined, the compiler will say, oh, the enum value is this. And if it's not, that won't be in the function name. So that's the way that we're actually getting all of the values. Now, granted, if you have an enum that has a value that is greater than 100, which is not that crazy of something to have, then this will miss that case. And you will try and index out of your array, and that will cause very bad things. In my particular application, this was the number of ranges that made sense to check. Over the
Can you change, could you have done an intrusive approach where you require there to be a max and a min defined in the enumeration? Something like that.
Yeah, so that's another option, right? Is basically every enum would need to have a value in it that would serve as some sort of a sentinel, some sort of a flag, right? And that is definitely a more robust implementation, I suppose. Well, I say robust, but it's yeah. It is a more manual way of going about it. And obviously, you know, if you define that as a specific number, or if that changes, if somehow you have one in the middle that's defined as a specific number, and then you go back to counting.
I don't know if you can write a concept or DNA on the existence value. Will that be a hard error?
No.
Looking at Jason.
I don't think so.
Okay.
I suspect
You
it
can't.
will be a hard error, right?
No, well, the problem
I think you would have to do it this way
is with, well,
in order to figure out if it was a valid.
if so,
If you can write a concept that requires those values exist in enumeration, then
no, you can't. You can't, because the valid values of an enumeration are all of the valid values in the underlying type. So if you have an enum struct, by default, it can legally be any integer.
yeah, no, but I mean, the name exists. Can you write a concept that the name exists?
Oh, the name, oh, yeah, it should
Require
be a name
min
lookup.
max.
It should be a normal name lookup required.
Huh.
Should be. Yeah.
I think what weird you could do like a using, you know, something that.
Either way, if it's right, actually, yeah, you should be able to.
You wouldn't be able to enforce that max was actually the max, I suppose.
That's true.
Yeah. If you use the using requirement, but not.
Well, you
That's
could
an
use
intrusive
using
document.
the concept, so that way you won't have to do the even way.
Yeah, that
That way then you could just check the max in place,
Oh,
right?
maybe.
We'll have to try it.
I don't know. Oh, no, you can't. I don't think you can put a using declaration. So
Use it on.
okay.
Somebody on my is trying it right now.
yeah. That is an interesting idea, because this is definitely the part that I'm like, doesn't feel great.
I think that's right. I think you need to do a constraint with an overload in the case that you just try it.
Mhm.
C++ option 6. You can just
Yes.
I'm very
I'm
excited.
expecting Dave to cover that in his talk.
I'm excited for reflection in C++ 26. Yes.
All of your loops here are standard algorithms. Did you find that the algorithm header was too expensive to include?
No, I didn't find the algorithm header, I think.
So this is max element. Yes.
I was looking at, for example, count algorithm is constant exponent in
They're all-
26, not before.
Oh, count.
And no,
It says since 26, I see constant exponent since 26 in CP reference.
Count, is it a numeric header or is it an algorithm?
no, it's algorithm.
Algorithm header.
It's context for 20. There might be a change to 26.
Oh, sorry, I was looking at this one. Constant exponent since 20, but it is removed in 26.
A lot of my process for finding, I suppose, algorithms that work was if we get one, if we have one, and we can compile, you know, and we're trying to break this up into enough layers that we can put them into the template parameters, that we will actually be able to get this to compile all the way to the end. And that was, I suppose, kind of the process, was just trying to string it out more. So I am 100% sure that there are better ways to do this. But once we actually get this,
Go back to source location flag.
yeah.
I'm just curious, at what point is this current function call being executed? Will it give you as value function, or is it the inline method?
This is an immediate function.
Yeah, did you catch that? It's not.
Yeah, this is just, I suppose, to called in context for context.
The fact that that's a const eval function means you will literally never see the body of that function in your compiled code. It doesn't exist. That function doesn't exist. Don't worry about it.
He was asking, can't very often get evil. We didn't define in function.
I'm just saying as eval doesn't exist. It's not a question of whether or not it'll be inline. The return value you will have at compile time. That's the meaning of a const eval function. Now the function itself, you'll never see a call to that function.
You know, it's essentially like a macro, right? You
said the M word.
It's like a background.
And then it deletes every single type.
It's a type safe background.
No, but macro can still emit code that would end up in your resulting binary.
Well, can you not like emit a lambda out of a const eval function?
Yes, you can return a lambda,
And
but
that will end up in
that's a
your
value.
binary.
That's an object.
Yeah.
That's not a function.
Well,
No.
You can return an array out of it and then just cast it to a function and call that array. Like
regardless, the result is it's effectively the result is inlined there. Is if you're thinking about it that way.
Yes, the result will be.
All right, so now that we can get the biggest enum, we can get some nice compiler errors. This made me very happy looking at it, to be able to see, oh, our static assertion failed because it's only valid if we define it for every value from min to max. So here we had our A, B, C, D, E. We didn't include E here, so we get a compiler error. That's actually really nice. And that's something that we don't get with standard map. Which is, you know, like I said, a pretty common solution because it is relatively straightforward. So this is nice, especially in cases where you're, you know, translating between things. You want to make sure that you have everything. And it is much, much better. I laughed the first time. So I have a huge monitor at work, right? I have one of those super ultra wides. And it's 2 4K screens side by side, basically. The first time I got a compiler error that filled up that entire screen. If I filled up, I laughed. It's amazing how quickly you can get to that. But this is much better. You can see the comparison reduces to 5 equals 4. 5 does not equal 4, so that doesn't compile. And we can look at this error as well. It says that we have our value defined multiple times. So this is that case I was talking about earlier. We defined A at here. We defined it again down here. This usually doesn't happen on purpose. This is usually something where it's like, oh, I need to come in and change this. You forget to remove the original value. Regardless, it's right there in code, so we should be able to see it. And we should be able to say, oh, we defined this twice. Now, obviously, you'll get that in like a map constructor as well. But it's something that you wouldn't get just looping through the list of helpers. So we put this all together, and now we can grab, basically we can put the whole thing together without having to know as much about the underlying types, about the underlying container. And that means that our syntax for this looks quite a bit nicer. So this attribute no inline here is just something on GCC to force it to put this in a different spot. And this is mostly because I want to compile with optimization, but I don't want the compiler to erase all of the code. So we get a value in here. All of this is just basically to make this do stuff function actually compile into things that it would be at runtime, while still being able to optimize. And we can see that we still get the same generated assembly as our array case, right? We are, sorry?
There was no jumps.
Yeah. We don't have any jumps. We're just indexing. We've got all of our, we're not storing any extra values in memory. And so, yeah, this is something that makes me very happy about C++, right? Is the fact that you can write something that looks more high level, that exists in more of the business logic language, and still compiles to the fundamental information that you need out of it. And we can take a look at what we're doing. Let's see. Oh, so this is, okay, can we change it at runtime? So the thing that I've switched out here is this is now constant int instead of const expr. And that is just building this type at compile time, but it's not making it constant. And so now we can do something like change it. This at function is returning a reference, and we can use that like we would use a map. We can say the index at example A is 7, and we can then read it back out, and it works. Let's see.
The compiler saw through that. Like in your LEA, you still get a 7. Why
Oh, yes, true.
why load it on the first line of do stuff? Like, what's the point of the mod there? Does anyone know?
So
The constant 7 is used twice in this function do stuff.
Oh,
Once
it's
on the
loading
first
it.
line and once on the last line.
true.
It seems like the usage on the last line would outbe the need for the first line.
But it's static.
Yes.
Visible
But
outside.
but it's local scope.
Yeah, but
Yeah, but
you still have to, you still.
The fact that I
says that you take the static every time you call.
yeah,
It's a dead store.
and no, but there's weird rules around statics, things that are not allowed to. I'm guessing it's falling into one.
Well, because I suppose theoretically you could have like a situation where there's something else that's reading that memory, right? Like if you
Yeah.
have it memory mapped.
Their point is that because the identifier is local to that function, there's literally no one else who can see that data.
Well, I guess if that portion of memory happens to be memory mapped.
Then that's undefined behavior. Yeah.
Oh.
Yeah, if you wanted that behavior, you'd have to mark it as false.
I think
Yeah,
it's
I don't know.
required to do that, right? Because it's static.
I imagine probably forcing it to no inline doesn't help the compiler figure things out, especially since this is a GNU specific attribute and it's, you know, kind of throwing that in, but it's mostly just a trick to try and get the assembly that we want to show up in a coherent place. A few kind of like semantic improvements that I've made after this are to basically require initializing a default value explicitly. Because I couldn't decide. I'm like, Should we zero initialize things? Should we call a default constructor if it happens to be there? Should we, and I kind of liked the case where it requires you to include every value to have that defined. So I left that actually as the default, so you'll get a compiler error if you don't define every value. And the default value, if I have the, well, that's not very helpful. This is a construct. This is a concept that defines, it's a struct that's just called default value of type T. And so you end up just passing that in. But this is, I suppose, just kind of more examples of extensions that you can make to make things more explicit. So you can write out, oh, I'm initializing this with a default value, or and this is, I suppose, cleaning up the default the default constructor, the one that will static assert if we don't have it defined for every value. And we can also define one with no default. And this allows us to do something like, if we build it with the no default, include an array of what are actually all of our defined values. This is something where sometimes you don't want to actually store the arrays, copies of things. Sometimes there's only one actually valid enum value. Obviously, everything's a trade-off for if you're doing sparse versus dense. You have to at least make, one other check to be like, oh, are we valid? If so, what's our index in our data? And yeah, these are, I suppose, the relevant constructors from the more modern version. Yeah.
I'm sorry, I didn't want to interrupt you. Go ahead.
Oh, and then I suppose adding other nice things to make the semantic usage more helpful was including views to iterate over the keys that are defined and to iterate over the values. Now, this can be obviously helpful when you're thinking of it as a map. You're thinking of it as a set of valid values that pertain to some sort of category. And yeah, I wish I had better, I suppose, kind of examples for these. I have reached I have reached my slides. So at this point, I would like to open it up for questions. Yes.
What's the time overhead? Or changing that from 5 to all of the special.
Well, it's
Especially using just everywhere.
yes. That's one reason why that value is particularly small. 100 is not a very big value, and that is because we get particularly bad compile times as we increase that value very quickly. I think the Magic Enum library that also does this kind of stuff has theirs at 256. But yes.
You put that in one translation unit and then use LTO to.
That would be the correct way to do it, yes.
So we just got a comment from the Discord, if you can try repeating the questions if they can't hear them remotely.
Oh, yes. That question was asking what's the compile time overhead for changing a 5 to not having to put that 5 in. And the answer is it's significantly more as you increase that the number of enums that you're checking. The question, I suppose, it hasn't been super noticeably significant for me. I haven't done extensive benchmarking of compile times of this particular aspect. It hasn't been bad, I suppose. It hasn't been bad to work with, bad to use. But if that is definitely something that you can hit problems on very quickly, especially as you're doing, kind of recursive template instantiations. This is something that's based on, just context for arrays, which helps a lot compared to a lot of the more traditional template metaprogramming where you have to do kind of everything recursively. That's something that's actually very nice about C++ 20, is that you can do a lot more kind of normal looking C++ code and still have it be const expert. Yes.
So your CI build is already like an hour, right?
Yes. For running tests and on the.
What's your normal build?
What's my normal build like when I build the whole solution? It's probably about 10 minutes. Yeah, but yeah, I usually only build one file at a time when I'm developing. But yeah.
How about cost? How bad it is and like relative to what? If you're doing it 10 minutes or an hour or something, adding it, that's 30 seconds. Not bad, but if you've got normally like a 10-second build, then it would be long.
True. And
there was like a limitation that you said is you can't have like an example of E out of 100 if you want. The whole maybe of 10 to 100.
yes,
Does
and
that fail on compile time if you try to put something in greater than that?
no, it does not. And that's something that actually I wanted to ask if it was. I don't think it is possible because our source of information about whether there is a valid enum is, did we check it? So I don't think it is possible to know for sure that we have all of them unless we check the entire space of the underlying type.
Yeah.
So yeah, Jason.
I have an API kind of design question. You're using .act, but those are not checked. It's not range checked, right?
They are in. There are. I took the assertions out
Okay, so
for slides. This is kind of the minimal functional stuff.
So in a
to
debug
try
mode, do you have asserts in there, or do you,
Yes.
you do not persist those to release builds? I mean,
I'm using asserts that someone. I didn't write these asserts.
yeah, sure. So they're not C's standard library asserts.
No, I do think that there are like parts of them that aren't used in release builds. I mean, fundamentally, we're not going to really be able to do very much to assert when the system is just running on its own for an embedded system sorts of situation. But
Right.
yes, there are assertions to check like, oh, have we actually initialized this? Do we have a valid value here? Yes.
Okay. I mean, I asked because the standard library .at implies a checked lookup. That's why I asked if it was consistent with the standard library. If I was using something.
Yeah, I didn't do that, I suppose, specifically because being consistent with the standard library. But it happens to be. Yes.
Have you looked at the code gen for like the naive switch statement case where your enum is like pretty sparsely populated, so your values kind of dotted around the white space as opposed to like a densely populated enum like you should have?
I have not, no, but that is interesting. I imagine it would probably revert back to, and you might have.
I have, and that will be in next month's talks.
Ah, there you go.
But I'm not going to be here.
Well, the answer is if your enum is pathological, the code gen ends up being a bunch of if else's or something very much like it, where it just says, compared to the first value, if it's that, do that. Compared to the second value, get that. Compared to the third value.
And you just went on cache locality versus having like an array.
Yeah.
But sometimes it will do crazy tricks like bit masks and stuff.
Yeah. I'm sure there's a lot to figure out. The compiler writers have been doing this for what? Decades.
And it depends on how sparse it
Yeah.
is and all kinds of
At a certain level of sparsity, you probably don't want a static array indexing over 8 gigabytes. But yeah, Chris.
Yeah, great talk. This is an idea that I didn't even consider was possible. So let's hear about this. I was recently using undefined behavior sanitizer, and I was trying to cast an invalid value into a scope enumeration, and I was flagged as UV. With the fix being that you have to explicitly specify the underlying type of the enum. Is that something that you've seen? Do you have more insight into whether that's like precisely true?
I'm not.
Doug, the valid
Scope enumeration is default to it.
and the valid range of values, is it?
Right, the unscoped ones. The rule is it just have to have enough.
It's the minimum number that's required to hold it all
And
down.
that is also in Clang now. It always was in DCC, but Clang.
Clang can check it out in Count's evaluation now.
Is it required to be the minimum?
Yes.
Okay.
Maybe this wasn't unscoped.
If you actually like try to check the underlying type, it's
Yeah.
gonna tell you int, but that's technically a lie.
Yeah, I asked what the specifics because when you're writing a switch statement and you're going to be exhaustive, you can kind of assume that no one will cast invalid values into it. And if it's undefined behavior, then you can actually assume that.
We'll go back to your main example though.
I want to make sure I know. what
Main
precise-
example of,
The one that actually has the word main in it with the reading value from CM.
oh, where was it?
That's towards the end. Like right here, the user can type in 99. And you have defined behavior on E equals, defined behavior on E equal, E2 equals, that's all defined. You have defined behavior until you get to index.at E1, and that's where you have your undefined behavior because he's going to index past the end of the array. It's total, that's all totally fine. Undefined behavior sanitizer is not going to catch this until you go past the end of that array.
I think we undefined is well defined. You're just off the end of your array.
No, that's undefined. Reading outside the array is undefined behavior.
Oh, because it's a truly size. Yeah.
Yeah, and we can, obviously add checks. Usually most of these reading the ats I have checked on debug builds, the builds that I'm looking at all the time, which is nice because it helps catch things. Again, I'm not writing code that's interfacing with users directly much. So a lot of this is kind of a more roundabout way of doing correctness checks. And that's the thing that was most compelling about trying to move to more const expr stuff for me, and trying to create some more intelligent types that match domains, the domain that I'm using them in, is the compelling advantages of const expr for correctness. And this is the thing that when I try and sell people on, no, we should really try and keep this so that we can use it in a compile time context. A lot of times you'll get the response like, oh, we don't really need the performance. And the performance is definitely a compelling use case for making things more const expr compatible. But I think the correctness for my application is more interesting. Being able to have a lot of static assertions, being able to have more type safety. I'm doing, I suppose, some experimenting with, I mentioned at the beginning that we have these configurables. that are based on enums that are currently maps to variance, but hoping that we can use more static types and get that to the point where we can do more checks, do more. It feels silly to me when you can write something in code that is incorrect. That shouldn't be possible. You shouldn't be able to just write a bug flat out. It should depend on some sort of input. Yes.
I think I have seen a use case for which the contains duplicate check like that might be a hurdle. It was something like it was the attrib ID enum, which had color in it, as in the item was color, and they were aliasing the same value for the British spelling, OU, and the American spelling, or just you.
Okay.
When they remarked like when you started a certain so the enum was basically like color equals 0.
Yes.
And then color with the OU equals 0. So you can
Oh.
like interchangeably.
So
Translate those the same.
that's valid. You can have a lot of different symbols that have the same number. You can't have a bunch of different numbers that have the same symbol.
Right, you only need to put one in, but you could then use any enum name that matches the same enum.
Yeah, you can have lots of names for a single number,
Yes.
but you can't have one name for a bunch of numbers.
True. And this assertion will fire if you had the American spelling and British spelling of color aliased to the same value, and then if we go to when we're actually getting this error, it would fire in this case because it's comparing the actual value of the enum, so it's checking 0 equals 0. If we wrote 0 in 2 different ways, it's still 0 to the machine, so it would still.
But if you just pick one of those, put it in there, would everything still work, or would there be other problems elsewhere?
It would still work.
I would argue the correct thing to do is to pick one.
Yeah.
Because like, what does it mean to have multiple? Like if I said like British spelling translates to 1, American spelling translates to 10, what do you do?
It would be the same number, but you don't have to write them both in this.
Yeah, but his point is that human error could make you accidentally put this different number for the 2. There's no way to check that.
Yeah. Well, this is the way to.
Yeah.
You check it like this, and that would correctly generate an error that says, "Hey, you have the same value twice."
Yes.
Or we just agree that the official language of C++ is American.
Raw Unicode support.
Is not American.
It's not, but the official language of the standard actually is American. That is actually true. American spellings are all that's allowed in the standard.
All right.
Could you show the ranges slide again?
Oh yeah. The ranges.
Yeah.
And I think the ranges have some things that I didn't include in the slides. Some of the
What is M values is the
array.
array?
Yes.
What's the take wild one?
It's
Keys and values? Is the array not right sized?
Oh,
let's see.
Well,
Oh. It is
oh.
going through the values in the array. So we have our
Those are the
enum constructor helpers.
and data value, right?
Yes.
Yeah, okay.
And it is checking while, because our size template parameter in this case is that max enum, or that enum array size from earlier. And so it's essentially going through. Why is it checking for that? Because it doesn't seem like a useful check.
Because if it's the size of the array is the size of the array, then just go over the elements of the array.
Yes.
And it's assuming that you're.
Oh, this is because this was the sparse optimization.
Oh.
And yeah, so basically only the bottom like values, I suppose, of, or like only some of the values of this array would actually be populated. This was something that I suppose added after the fact, and then yes, that was it's a an extra layer of indirection, because you would have to look up where in your index you are, right? And you would index the enum basically to if it is valid or not, and use an integer to an integer of some sort to index into your values. So that's why it is doing that, because yes, that also doesn't make very much sense. It's like, well, shouldn't all of those be defined? No. And yes, I think it's using a sentinel enum that is outside the valid, like, defined range. I wish that I had my whole code base here at this point. But yes, that's some aspects and additions that I have not included in the slides. Any other questions? Okay.
Thank you.
All right.